Hey everyone, ready for another deep dive?
Let's do it.
Awesome. Listeners, this time you've all really outdone yourselves.
Oh, yeah.
Yeah, the stuff you sent in about black holes this week is, well, it's pretty mind-blowing.
I'm intrigued.
Oh, you will be. Yeah, we've got this incredible in-depth breakdown of, like, everything black holes.
Nice.
So we're going to try to tackle some of the big questions, like how do they even form?
Right.
What happens if you fall into one? And just how massive can these things get?
All good questions.
Yeah.
So I guess we got to start somewhere, right?
Yeah. Let's start at the very beginning, like a cosmic life cycle kind of thing.
Okay.
This material you sent in, it lays out how stars are born, right? From these massive clouds of hydrogen
Right.
collapsing under their own gravity.
Yeah. And as this cloud collapses, the hydrogen atoms at the core, they're squeezed together with so much force
Oh, wow.
that they begin to fuse, forming helium and releasing this immense amount of energy. Yeah, it's like a giant cosmic pressure
Yeah.
cooker, right?
Exactly.
But wait, so this energy that's being released,
Yeah.
that's actually what's pushing outward.
Yes.
Counteracting that inward pull of gravity.
Exactly. It's a delicate balance, really.
Yeah.
For a good chunk of a star's life, these two forces, gravity and outward pressure, they're kind of in a standoff.
That makes sense.
But things get really interesting when you look at stars that are way bigger than our sun.
Okay, yeah. What happens with those stellar heavyweights?
Well, they have the power to fuse elements way heavier than hydrogen.
Oh, wow.
So the fusion creates, increasingly heavier elements like building up through the periodic table.
So like carbon, oxygen, all that.
Yeah. And so on until they hit iron.
Iron. Is there something special about iron in this whole process?
There is. Fusing iron actually uses up energy instead of releasing it.
Oh, wow. So it's like the opposite of what was happening before.
Exactly. And as this iron builds up in the core, it's kind of like a ticking time bomb.
Yeah.
Eventually, the core can't take it anymore. The gravity's just too much.
So no more outward pressure.
Nope,
What happens? Does the star just kind of fizzle out?
not quite. The core implodes.
Implodes.
Yeah, it collapses in on itself super fast, like a quarter of the speed of light.
Whoa, hold on. A quarter of the speed of light?
Yeah, it's mind-blowing.
That's insane.
And this implosion sets off this shock wave,
Okay.
which blasts the outer layers of the star out.
Outward.
Yeah, in a supernova. And get this, all the heavy elements in the universe, they're forged in these explosions.
Seriously?
Yeah, like the stuff that makes up you and me, even our planet. It all came from a supernova.
That is incredible. Okay, so the death of a star is really the birth of so much more.
That's the beauty of it, right?
It is, but what about the core itself? Like, what's left behind after all that?
So there are two main possibilities. Sometimes the core collapses into something called a neutron star.
Okay.
But if the star is massive enough, it keeps collapsing until it becomes a black hole.
A black hole. That region of space-time where gravity is so strong that nothing, not even light, can escape.
That's the one.
And this is where we get to the event horizon, right?
Exactly. The event horizon is that boundary around a black hole
Huh?
where escape is impossible.
The point of no return.
Yeah. Once you cross it, you're heading straight for the center of the black hole, no turning back.
Okay, so if we could actually see a black hole, it wouldn't be a hole at all.
No.
It'd be like this perfectly black sphere
You got it.
because no light is reflecting back to us.
It's like a cosmic silhouette.
Yeah.
We're seeing the absence of light, a shadow against the universe.
That makes sense, but if the event horizon is that spherical boundary,
Uh-huh.
what's actually at the center of the black hole? Like, what's the whole part?
That, my friend, is the singularity.
The singularity.
Yeah, a point of infinite density.
Infinite density.
Yeah, where physics as we know it kind of breaks down.
Breaks down. So even with all our science, we don't really know what happens there.
Not really. All the matter that falls into the black hole is supposed to end up there.
Okay.
But it's so dense, the gravity's so strong,
Right.
that our current laws of physics just can't describe it.
So it's like the ultimate unknown, the
Mm.
place where our knowledge just stops.
It is, and that's what makes black holes so captivating.
Right.
They push the boundaries of our understanding, make us question everything we thought we knew about the universe.
I mean, yeah, it's kind of unsettling to think
Yeah.
about, this point where we can't even apply our basic physics anymore.
Right, and with the singularity, we're talking pure theoretical physics here.
Yeah.
Some physicists think it might not even be a point.
Oh.
Yeah, maybe a ring, a fuzzy region, or even, get this, a gateway to another universe.
A gateway to another universe.
Who knows? The possibilities are endless.
Okay, my mind is officially blown. I think we need to, step back for a second
Okay.
and debunk some common myth about black holes.
Good idea. Like what?
Yeah. Like, the idea that they're these cosmic vacuum cleaners sucking up everything in sight.
Yeah, that's a big one. But this information you sent in,
Yeah.
it does a great job of clearing that up.
It does. They have a great example, actually.
Oh, yeah. Tell me about it.
Okay, so imagine we replace our sun with a black hole of the exact same mass.
Okay, I'm imagining.
What do you think would happen to Earth?
Well, first thought, no more sunlight, which is a problem.
Yeah, we'd freeze pretty quickly.
Yeah, but would the black hole's gravity suck us in? I don't think so.
You're exactly right.
Really?
Yeah, because remember, gravity's all about mass.
Right.
And since the black hole would have the same mass as our sun, the pull on Earth would be identical.
So our orbit wouldn't change at all?
Nope, not a bit.
Huh. So it's not like this monster just gobbling everything up.
Exactly.
It's more about that event horizon.
Right.
You stay outside of that boundary, you're good.
Safe and sound.
But cross that threshold,
That's where things get dicey.
and by dicey you mean terrifying, right?
Yeah, falling into a black hole can't be a good time.
Definitely not on my bucket list.
But, hypothetically speaking,
Okay, hypothetically.
what would actually happen? What would it be like to fall into a black hole?
Well, first things first. Time gets really weird near a black hole.
Oh, yeah, I remember something about time dilation.
Exactly. The closer you get to the event horizon, the slower time moves for you, relative to someone watching from a safe distance.
Wait, so if I was watching you fall in, you'd look like you're moving in slow motion.
Pretty much.
Oh.
And it would just be a visual thing.
Oh.
Like your actual clocks would be ticking slower from my perspective.
Wow. So from my point of view, you'd be frozen in time at the edge of the black hole.
Kinda, yeah. And the light coming from you would slowly redshift.
Redshift.
Yeah, it would shift towards the red end of the spectrum until you eventually faded out completely.
That is seriously creepy.
Right.
Okay, but what about from your perspective? As the one falling in, what would you see?
Well, that's where things get really trippy.
Okay, I'm all ears.
From your point of view, you wouldn't notice time slowing down at all.
Really?
Nope, your clocks would seem normal. But the universe around you, that's a different story.
Okay, what would happen?
It would look like it's speeding up, fast forwarding.
Hold on, so you're falling into this black hole and you see the entire universe in fast forward, like a cosmic time-lapse video.
Exactly. Stars evolving, galaxies being born and dying, maybe even the end of the universe itself, all happening super fast.
That's incredible and absolutely terrifying at the same time.
Yeah, it's a lot to take in.
So, assuming you've somehow survived long enough to process all that, what's next? What's waiting for you at the bottom of this cosmic abyss?
Well, that's where things take a bit of a dark turn, literally and figuratively.
Oh no, what do you mean?
There are two main theories about what happens inside a black hole,
Oh, lay it on me.
and neither one is particularly pleasant.
Okay, what are the options?
Option 1, spaghettification.
Spaghettification. What in the world is that?
So as you fall deeper into the black hole, the gravity gets more and more intense, right?
Yeah.
But it's not evenly distributed.
Oh no, I have a bad feeling about this.
The gravity on your feet would be way stronger than the gravity on your head.
I don't like where this is going.
Imagine being stretched like taffy, but it's your entire body, pulled into this long, thin stream of atoms.
Oh, ouch. So death by extreme stretching. Not exactly how I pictured going out.
Yeah, not the best way to go, but there's another possibility.
There's more. Okay, what's the other option?
Some physicists think there might be a firewall just beyond the event horizon.
A firewall, like in a computer.
Not exactly. It's more like a region of intense energy where space-time itself breaks down,
Oh, wow.
and anything that hits it is instantly incinerated.
Incinerated. So either death by stretching or death by immediate burning? Those are my choices.
Pretty much, yeah. But hey, there's a silver lining, sorta.
A silver lining in this scenario.
Well, the time it takes to reach either of those fates depends on the size of the black hole.
Okay, how so?
Smaller black holes, they do the job quicker. Supermassive ones give you a slightly longer but still terrifying journey.
Slightly longer, huh? Well, that's strangely comforting, I guess.
Yeah, a bit of a cosmic consolation prize.
Okay, but speaking of different sizes, I know not all black holes are created equal.
Right, there's quite a variety out there.
This research you sent in, it talks about that too, right?
Yep, it dives into the different types of black holes, from tiny ones to absolute monsters.
Monsters. Okay, now I'm really curious.
We've got stellar mass black holes, just a few times the mass of our sun, but only like the size of a small city.
Okay.
And then there are the supermassive ones, billions of times the mass of the sun.
Billions. That's
Yeah.
almost impossible to comprehend.
Right. Like the biggest one we know of, S50012 plus 81, it's a mind-boggling
Mm.
40 billion times the mass of our sun.
Seriously.
And it's huge.
Yeah.
Its event horizon alone would span a distance 47 times greater than the distance from our sun to Pluto.
Okay, hold on. That's like our entire solar system would be a tiny speck compared to that.
Exactly. Makes you feel pretty small, right?
It does. And to think, astronomers believe these supermassive black holes are at the center of almost every galaxy.
Yeah. Including our own Milky Way.
So these monstrous objects aren't just out there in the distant universe, they're
Yeah.
part of the very fabric of galaxies.
They shade how galaxies form and evolve over billions of years.
Yeah.
It's pretty amazing when you think about it.
It is. But okay, I gotta ask you something, and this might be a bit sci-fi.
Go for it. I'm intrigued.
We know black holes warp space and time so much.
Mm-hmm.
Could they somehow be used for time travel?
The age-old question of time travel. It's definitely a fascinating idea.
Right. And black holes seem like the perfect candidates.
Well, theoretically it's intriguing, but there are a lot of complexities.
Okay, but hypothetically speaking.
Hypothetically, let's dive into the possibilities.
Yes, lead the way.
So one concept that often comes up is wormholes.
Wormholes, like shortcuts through space-time.
Exactly. Imagine a tunnel connecting two distant points in space-time. You enter one end and pop out the other, maybe light years away, or even in a different time.
Okay, so I could jump into a black hole here on Earth
Hypothetically.
and end up on the other side of the galaxy, or in a different era. Sounds like a great way to skip rush hour traffic.
Huh. In theory, maybe.
Yeah.
But there's a catch.
Oh, always a catch.
We've never actually seen a wormhole.
Really?
Nope, we're purely theoretical for now.
Right. Good to remember the difference between science fact and science fiction.
Exactly. And even if wormholes do exist, they probably wouldn't be those nice, stable tunnels you see in movies.
Oh, no.
The gravity involved would likely cause them to collapse instantly.
So not a reliable mode of transportation, then?
Probably not.
Okay, so wormholes are out. Are there any other theoretical ways to use black holes for messing around with time?
Well, there's another possibility, but it relies heavily on that time dilation we talked about.
You mean the whole time slows down near the event horizon thing?
Exactly.
Mhm.
Theoretically, if you could get really close to a black hole
Yeah.
without actually falling
Right.
into it, you could experience time at a much slower rate than the rest of the universe.
So, like, I could spend a few years orbiting a black hole,
Yeah.
come back to Earth, and everyone I knew would have aged decades.
That's the basic idea. It's like a one-way ticket to the future.
Wow, a time dilation trip to the future.
Pretty cool, right?
Yeah.
But of course, there are challenges.
Let me guess. Building a spaceship that can handle the insane gravity and radiation near a black hole.
That's a big one. We don't have the technology for that, not even close.
Right, and even if we did,
Yeah,
you'd be stuck in the future. No way to get back to your own time.
true. It's a one-way trip.
So, black hole time travel might be fun to think about.
Yeah,
But it's best left to the theorists and sci-fi writers for now.
for now, definitely.
Okay, so we've explored the formation of black holes,
Yeah.
their structure, the whole event horizon thing, even the wild possibility of time travel.
All the good stuff.
Anything we've missed.
Well, there's one final and pretty profound question. What role might black holes play in the ultimate fate of the universe?
Whoa, okay, we're getting existential now.
Yeah, this is big picture stuff.
I'm ready, bring it on. How might the universe end? And where do black holes fit into all of that?
All right, let's dive into the cosmic unknown then.
Perfect. Welcome back, everyone. I don't know about you, but
Still thinking about those black holes, huh?
yeah. I'm kind of stuck on that whole event horizon thing.
Yeah.
And, well, let's just say falling into a black hole is definitely not on my bucket list.
Agreed. Not a fun way to go.
Not at all. But before we get too caught up in the whole, spaghettification thing,
Right.
let's switch gears a bit.
Okay, what did you have in mind?
Well, we were starting to touch on this at the end of the last part
Yeah.
about supermassive black holes.
Oh, yeah, those big guys.
Yeah, and how they're like right at the heart of galaxies.
It's true. They're more than just passive bystanders.
So they're not just sitting there doing their black hole thing.
Nope. They play a huge role in shaping the galaxies around them.
Okay, now I'm really interested. Tell me more about this cosmic dance between a supermassive black hole and its galaxy.
All right, so picture this.
Yeah.
You've got matter, gas, dust, even whole stars getting pulled towards the black hole.
Uh-huh.
But they don't just fall straight in.
Oh, what happens then?
They form a swirling disk around the black hole.
A disk.
Yeah, it's called an accretion disk.
Accretion disk. So it's like the cosmic whirlpool?
Exactly. And as this material spirals inward,
Yeah.
it gets superheated from friction and gravity.
Oh, wow. Must be getting pretty toasty in there.
Yeah, it creates this incredibly energetic environment,
Okay.
generating tons of radiation all across the spectrum, from radio waves to X-rays.
So these supermassive black holes are like, what, giant cosmic engines powering these insane displays of energy?
That's a great way to put it.
Right. But it gets even crazier.
Oh, there's more.
Yeah, these accretion disks, they can launch jets.
Jets.
Yeah, powerful jets of particles and energy.
Shooting out from the black hole.
Yeah, they blast out from the poles of the black hole, extending thousands of light years into space.
Hold on. I thought everything just fell into a black hole. How can anything be shooting out?
It's one of those things that seems kind of backwards, right?
Totally.
But these jets, they're thought to be created by magnetic fields interacting within the accretion disk.
Magnetic field, so it's like a giant cosmic electromagnet.
Kind of, yeah. It's a complex process, but the result is these incredible beams of energy.
Beams of energy shooting out thousands of light years.
Yep, and they have a big impact on the surrounding galaxy.
Okay, what kind of impact are we talking about?
Well, for one, they can actually influence star formation.
Really?
Yeah, the energy from the jets can heat up nearby gas clouds,
Yeah.
and that can stop them from collapsing and forming new stars.
So in a way, these black holes are controlling how many stars are born.
Exactly. It's like a cosmic balancing act.
It's a balancing act.
Yeah, too many new stars can make the galaxy unstable.
Right.
But too few can stunt its growth.
So the black hole is keeping things in check.
It seems that way. Pretty amazing, right?
Yeah, we've gone from thinking of black holes as just these destructive forces.
Right, these cosmic monsters.
Exactly.
Yeah.
But now we see they can actually be essential for the growth and evolution of galaxies.
It's a totally different perspective, isn't it?
It is. It shows how everything in the universe is connected, you know?
I love that.
Even these seemingly chaotic objects can have a profound impact on creation and order.
Mind-blowing. But okay, before we move on,
Yeah.
there's something I've always wondered about, and it might be a bit out there.
Hit me with it.
So we've established that black holes warp space and time like crazy, right?
Definitely.
Could they maybe somehow be used for time travel?
Time travel. The question that never gets old.
Right. And black holes, they just seem like the perfect candidates.
I mean, it's a tempting thought, isn't it?
Totally. So is it possible? Could we use black holes to travel through time?
Well, like most things with black holes, it's complicated.
Okay, but humor me for a second. Hypothetically speaking.
Hypothetically, sure. Let's play with the idea.
Awesome. What are the possibilities, even if they're far-fetched?
Okay, so one concept that pops up a lot is wormholes.
Wormholes, like those tunnels through space-time.
Exactly. Imagine a tunnel connecting 2 points in spacetime. You go in one end and come out the other, maybe light years away, or even in a different time.
Okay, so I could jump into a black hole here and now
Yeah.
and pop out on the other side of the galaxy, or maybe even in a different era.
Theoretically, it's possible, but there are some big ifs here.
Oh, like what?
Well, first of all, we've never actually seen a wormhole.
Really?
Nope, they're purely theoretical.
So more science fiction than science fact at this point.
Exactly.
Okay, good to know.
And even if they do exist, they're probably not going to be those stable, traversable tunnels we see in movies.
Oh, that's a bummer.
Yeah. The gravity would likely cause them to collapse right away.
So not the most reliable way to travel then?
Probably not.
Okay, so wormholes are out. Any other theoretical ways to use black holes for time shenanigans?
Well, there is another possibility, but it leans heavily on time dilation.
Oh, right. The whole time slows down near a black hole thing.
Yeah, that's the one. So theoretically, if you could get super close to a black hole,
Uh-huh.
without crossing the event horizon, of course,
Right, gotta avoid that.
you'd experience time way slower than the rest of the universe.
Okay, so I could spend a few years hanging out near a black hole,
Yeah,
come back to Earth, and everyone I know would have aged decades.
that's the idea. It's like a one-way trip to the future.
Wow, a black hole-powered time machine?
Kind of, yeah. But as you can imagine, there are some major challenges.
I bet. Like building a spaceship that can survive near a black hole.
That's a big one. We're nowhere near that level of technology.
Right, and even if we could,
Yeah,
you'd be stranded in the future, no way to get back to your own time.
true. It's a one-way street.
So time travel via black holes, it's a cool concept.
Definitely fun to think about.
But probably best left to the theorists and sci-fi writers, at least for now.
Agreed.
All right, so we've covered the formation of black holes,
Uh-huh.
their structure, the event horizon, even the mind-bending possibility of time travel.
Sounds like we've covered a lot of ground.
We have, but is there anything we've missed? Anything else about these fascinating objects?
Well, there was one final question, and it's a pretty big one.
Oh, I'm intrigued. What is it?
What role might black holes play in the ultimate fate of the universe?
Whoa, okay, now we're talking. This is getting deep, even for us.
Yeah, we're going full-on cosmic here.
All right, I'm ready. How might the universe end? And how do black holes factor into all of that?
Well, to answer that, we need to talk about some of the theories out there. And trust me, they're pretty wild.
Bring it on. I'm all ears.
Hmm.
Okay, so we're talking the end of the universe.
The big finale.
This is heavy stuff. Where do we even start?
Well, one scenario is the big freeze.
The big freeze?
Yeah, it's based on the idea that the universe keeps expanding forever, you know?
Yeah, right. And that expansion is driven by dark energy.
Exactly. Dark energy, that mysterious force pushing everything apart.
And as the universe expands, everything gets more and more spread out.
Right. Stars burn out, galaxies drift apart.
So it just becomes this cold, dark, empty place.
Pretty much. Yeah, and in this scenario, black holes, they become the dominant objects.
Dominant. What happens to everything else?
Well, stars die out, galaxies move away, and black holes just kind of slowly grow, pulling in any matter that's left.
But even black holes aren't eternal, right?
That's true. Remember Hawking radiation?
Right. They slowly evaporate over, like, ridiculous amounts of time.
Exactly. Even those supermassive giants, they eventually radiate all their energy away.
When what's left?
Not much, just a faint trace of Hawking radiation.
So in the big freeze, it's not a bang, it's a whimper. A slow, cold death, even for black holes.
Yeah, kind of depressing, isn't it?
A little bit. Are there any other scenarios? Anything a bit more, dramatic?
There is one. It's called the Big Rip.
The Big Rip. Okay, that name sounds a little intense.
It is. In this one, the expansion of the universe, it doesn't just continue. It accelerates faster and faster.
So not just spreading out, but like being pulled apart.
Exactly. And eventually, that expansion, it gets so strong,
Yeah.
it overcomes every other force.
Every force.
Gravity, electromagnetism, even the forces holding atoms together.
So the universe basically just unravels.
Pretty much.
Yeah.
Galaxies are ripped apart, stars are torn away, planets disintegrate, even atoms get shredded.
Okay, that's definitely more dramatic than the Big Freeze.
For sure.
But where do black holes fit into all of this? Can they survive the Big Rip?
Well, even with their incredible gravity, no, they wouldn't be immune.
Really?
Yeah, the expansion would eventually overpower even a black hole.
So even black holes get ripped apart.
Yep, it's a pretty violent end. Everything dissolving into this sea of particles.
So we've got the slow fade of the Big Freeze and the universe shredding Big Rip.
Two very different endings.
Are there any other possibilities?
There are some other theories, like the Big Crunch.
The Big Crunch.
Yeah, where the expansion reverses and everything collapses back in on itself.
Like a reverse Big Bang?
Exactly. But right now, the evidence points to a universe that keeps expanding.
Right. Whether it's a slow fade or a dramatic rip.
Either way, it's going to be interesting.
So no matter how it all ends, it seems like black holes play a pretty important role.
They do. They're shaping the universe throughout its entire life, even influencing its ultimate fate.
This has been an incredible journey,
It has?
We started with the birth of stars, then black holes forming.
Right.
Explored the event horizon, even talked about time travel.
All thanks to those amazing questions from our listeners.
Absolutely. I'm leaving this deep dive with a whole new appreciation for the universe.
Me too.
Just how vast and complex and strange it all is.
And the best part?
What's that?
We've only just begun to understand it all.
Exactly.
Mhm.
So much more out there to discover.
Absolutely.
So to all you deep divers out there, keep looking up, keep asking questions, and never stop being curious about the universe.
Because the universe is full of mysteries and wonders.
Waiting for us to uncover them.
Exactly.
Who knows, maybe one day we'll crack the code of those amazing black holes.
Maybe one day.
Thanks for joining us on this incredible journey, everyone.
Until next time.